All right, so today we're going to talk about loops. Finally, we're going to be able to do this. Like, we got some code. We'd like to come back around and keep rerunning that code. So we've done that so much in Scratch. It's wonderful. We understand the power of it. Let's get it in Python finally. All right. So it'll take a little bit to get there. I also want to talk about a concept called lists that will help us as well. Just a way of holding a bunch of stuff. So that's new as well. But I guess even before any of that, let's just talk about messing up. Because in Scratch, you couldn't mess up. There's no errors in Scratch, kind of. It's just like you had a bug in your code, but it would still run. In Python, it's not the same, right? In Python, you can spell something wrong, and then Python will yell at you. Right? It'll put red marks on the output. It will be unhappy. And so there's a couple kinds of errors. The ones that you will run into in Python, the two main ones are called runtime errors and logic errors. So I should at least define them for you. All right. So a runtime error, kind of as the name implies, it's something that happens. It's something bad that happens as your program is running during the time that it is running. Okay. It's an error that Python cannot fix. It's your fault, right? It's unrecoverable, and it's happening as your program is running. So Python didn't know before the program started running that there would be an issue, but it found an issue as it was running. All right, and then it just stops itself because it can't continue. It's like the universe is so messed up right now, it has no clue what to do. So it just stops the program at that point. A good example of a runtime error is like division by zero, because that's an undefined answer, right? So if you try to divide by 0 in Python, then it's going to give you a runtime error saying, I don't know what you wanted here, but I don't have an answer, so I'm going to stop the program. All right? So let me show that to you. I will open up idle and make a new file for today. I have a few files to write, but this will be the first one. I wish I could change the default sizes of all these. But let's see. What lecture number are we today? So I'll make a lecture 19 folder for us. We'll save that in there. But you can save yours wherever you want. And I'll call this runtime error.py. So okay, let's do division by 0. So let's make it very subtle though. How about this? This will be very clear that Python couldn't know ahead of time that there would be an issue. Let's ask the user, hey, enter a number. See where I'm going with this? And then let's take it as a number, so convert it to an int. Let's say they're only going to give us whole numbers. So the user's going to give me a whole number. I'm going to convert it to an int, make sure it's a number, and put it in an n variable. And then what? I'll be like, print 42 divided by that n, whatever the user gave me. We could make it look pretty with the print statement, like 42 divided by n is colon space. Like once you add the commas, it will add spaces in between. But this right here, it will do the math and then print out the answer. Yeah, that's what will happen. So let's watch it work and not work. Because it could be fine, right? If the user types 2, it will divide 42 by 2, and it's like, oh, yeah, that's 21. Does that make sense? But if I did it by 0, if the user typed 0, you see how Python didn't know that was coming. Like Python can't control the user. I type 0 there, though. It's like, nope, it does not work like that. Division by 0, error, runtime error, and it stops the program. But it is trying to help you. Like it tells you what the problem was as just one word, I guess. 0 division error. It tells you the line number where things were happening. So you can tell what line number you're on. It's like line 2. Of course, you can count 1, 2. But if you're ever like confused about where you are, you can always just like put your cursor somewhere in idle. And down here at the bottom, it tells you what line you're on, as well as what column you're on of that line. But that's helpful to find the error if you can't track it down. You have a big file. But it's being as helpful as it can. And a runtime error stops the program. So if we had more code down here, like hello, you want to print something else, then if we type 2, of course, like it'll do the stuff and run this line eventually. But if we type 0 and we hit the runtime error, it will stop the program the second that error happens. So it will not try to continue and print hello. Okay, it just like all bets are off. Python is confused. It's like, all right, something is so wrong, I need to just stop everything. And so it stops the entire program. Okay, so that's a runtime error. Are there any questions about that? We run into them already? maybe. So yeah, there's that one. That's a main kind of error that you'll see in Python. The other kind of error is the one that is carried over from Scratch. It's called a logic error. All right, this is the subtle kind. Another word for logic error is a bug. You've probably heard that word before, right? So yeah, a bug is, or a logic error, is when like you were trying to do one thing, like you thought that the code was going to do one thing, but it really did a different thing. All right. And so like it still runs to completion, you just get like the wrong answer. That's what a logic error is all about. So for example, here would be a logic error, like set I to 42, and then I'll make a variable called I plus 2, and I'll set it to I plus 1. All right. Do you see how this code, I mean the naming at least, kind of hints at the fact that there's something going wrong there. I don't think the program's going to end because of it. You'll just get the wrong answer. You're off by 1, kind of. Okay? I hope you see that. And so that is, of course, always a thing. You can always mess up the code slightly. If it runs and you get the wrong answer, logic error. It's very hard to track down sometimes, but we're used to it from Scratch, probably. All right, so those are like the 2 main kinds of errors that you'll see. Are we ready for a new topic? Actually, things that could go right. Let's talk about a thing called lists in Python. All right. So the idea of a list is it's a place where you can hold a bunch of stuff in one spot. All right. That's something that we don't have right now. So a list is just like a kind of variable. You can think of it that way. It's a type, really. It's a way of holding a bunch of stuff in a single place. Usually you put it in a single variable. Because let's say one day you're writing like a video game, like a 3-dimensional video game, and you want to store where like your character is in your video game, where all the enemies are in the video game. So like you've got a 3-dimensional coordinate system, yeah, X, Y, and Z. Dun, dun, dun. Dun, 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 dun. Let's say like, I don't know, your enemy is at this coordinate, 2, 3, 5, 2, 3, and then go up 5, right there, 2, 3, 5. Yeah. How do you save that fact? Well, right now, all that we can do is like make a bunch of variables, make an X variable, a Y variable, and a Z variable, and set them to those coordinates. Like the enemy is at 2, 3, 5, and they're all in separate variables. And you got to pass those around. You see how kind of tedious that's going to be? Like if you have, let's say you have like 100 enemies on the screen, they all need coordinates. So you're going to make an X1, X2, X3, Y1, Y2, Y3, Z1, Z2. That gets really hard, right? It's really tedious. So a better way is to use a list. A list is a way to hold a bunch of stuff at once where order matters. So here's how you make a list in Python. You just say with the square brackets, stuff, and then you put the stuff between commas. So this right here, we read it as the list holding 1, 2, 3. Right? And then the order is important. Like you can't like, this is not the same as the list 2, 3, 1 or something. The order matters. But that would be another list in that order, right? So if I wanted to store this coordinate in one spot, I could say this. I could say like make the list 2, 3, 5 and set that equal to P or something. See how useful that's going to be? They're all set next to each other. It's beautiful. It's just one spot. It's a one-stop shop for all of those coordinates. Like P itself is a variable that holds the entire list 2, 3, 5. Does that kind of make sense? See, a list is like a type. It's a new type of things. It's just a big chunk of stuff all together. It's, as far as Python cares, it's one thing. So here, let me show that to you. And it does have types that are involved here. Let's see. Yeah, so let me show that to you. I'll make a file called lists.py. And let's make some list variables. So might as well just do the one. 2, 3, 5, just like that. There's my list. It's called P, and like it's all one thing. It's all one big chunk of stuff. It's all a bunch of numbers all at once in one name. It's really nice. It's all packaged together. So if I print P, there's my 2, 3, 5. It's all together. It's really nice, really nice. And then it is a type, right? There inside of the list there are ints, yes. So 2, 3, and 5, they're all ints. But at the outermost level, it is a list. So the type of P, if you ask for it, like print that for me, Python. it's just a list for now. If you go inside of it, of course, you can have the little pieces are ints, but it's at the outermost level, it's a list. So maybe the most specific way to talk about this list to describe its type would be it is a list of integers. Something like that. All right? Does that make sense so far? It's just one big chunk of stuff, comma separated. All right. If we are good with that, let's see what I want to do next. There's plenty of more things you can do with lists. So first of all, one way to make them is, of course, like spell out all the values. That's totally fine. But you can also build up a list, like slowly but surely keep adding things to it. There is a plus operator on lists. All right, so you can make lists from scratch if you would like. There's an empty list where it's like that's a list holding nothing at all, just bracket. And then you can also add together two existing lists. Like if you have the list 1, 2, and then the list 3, 4, you can add them together with the plus operator. So plus works on lists. And what it will do is it will build a bigger list, a third list, that holds all of those elements in order. We call the pieces elements of the list. Okay? So yeah, that's kind of how that looks. And so you can like start a variable with emptiness and just like keep on adding new elements at a time, kind of like that. I would build up the list just 1, 2, or something. That kind of makes sense. That's how you could do that, slowly but surely. I'll eventually show you an example of that. So that's the thing. And then also, if you want to know like how big your list is, like how many things are inside of it, I still haven't told you how to get like, how do I get the 2 out of this right now? I still need to tell that to you. But like, if you want to know how big the list is, there's a len function that's just baked into Python. There's no library that's needed. You say len, and then you give whatever the list was, or your variable that was holding the list, and it will give back how big that list was, how many elements are in it. Okay? So all those terms make enough sense for now? New words for sure, but I think you're getting it. So yeah, we can build up new lists. We can print the length of P to know how many things are in it, so that we can go and access them later. But Python knows there's 3 things in this list P right now. All right, and then you can build up your other list. Like start it at, like I said, 1, 2 plus 3, 4. Build up a bigger list, 1, 2, 3, 4. The empty list is kind of like the unit, like empty list plus 1, 2 is still just the 1, 2. It adds nothing, but you could start like a variable like that, just like add new things one at a time by adding lists of just one element. That kind of makes sense. So you can use the plus on a bunch of lists to bring together their elements, and like a good starting place is usually the empty list if you're not ready for anything yet. But yeah, that's a way to hold a bunch of stuff. And now kind of you need to be able to go into the list. Like I need the 2 out, I need the 3 out, I need the 5 out. So let's do that. That's kind of the last major piece of the deal here. So let's see. The answer is, if you want to go and get a piece of a list out, you can index into. That's what we say. You access the pieces using things called indices. All right. So let's say that I've got a list. I'll call it X this time. X holds 5, then 6, then 7. And I guess I drew lists like this before, but let me draw it in a better way now. This is kind of what the list really looks like. It's got the 5, the 6, and the 7 together, but they're kind of separate at the same time. X holds all of them, but you can pick out the ones you want, right, with indices. And it's just like a number that represents where in the list the piece is. So indices always start at 0. The very first element is at index 0 always. So the index of the 5 is index 0, right? And then it goes 1 for the 6 and 2 for the 7. It's always starting at 0, right? So if you have a 3-element list, index 0 is the first thing, index 1 is the second thing, index 2 is the third thing. Try to keep that straight because it's as we're first learning it, it's hard, and you probably want to think that, oh, it starts at 1. It does not start at 1. In computer science, we like to start at 0. So you can access each element, that's a new key term, of a list with indices. Element is kind of the word of the day. And they start at 0. You go to the 0th index to get the first thing out. And here's how you go to an index, now that we know that the indices exist. You say the name of your list, and then you give brackets, like you're making a list, But in between the brackets, this time you give the index you want to visit. All right, that's the secret. And so x of 0, go to x at index 0. This will give back and pick out the 5 for you. Does that kind of make sense how that's going to work? That will go to the piece of your list. X, go to index 2. That will give back the 7. All right. So yeah, just be careful that it does start with zeros. Like if you want the second thing, you gotta go to the index number 1, the 1th index, the 2th index, whatever. So yeah, that's the syntax. And you can also go backwards. Python is nice enough to give you alternate indices. If you want to go backwards, you don't have to really worry about the length of your list. You can just start at -1. -1 is always your last element's index. So instead of worrying about is it 2, you can just say go to index -1 of the list, and it will give you the last thing always. And so you can work your way from the right side with negatives, like -1. This is index -2. This would be index -3. So you do have 2 options always for the pieces. Just however you want to think about them, like starting from the last thing, start at -1, go make it smaller, or starting from the first thing, start at 0, make it bigger, whatever you want. All right. So yeah, every element has 2 indices. One's like either positive or 0, and then the other is negative. Okay. So if I wanted another way to get the 7, then would be to go to index -1. So x, go to index -1, will give me back the 7 as well, and then like -2 would give me back the 6, or I could have gone to index 1, or 1 would have given me back that 6 as well. Okay, I think that that'll do it. Does that make enough sense? Questions? All right, those are. I promise this is. There's a reason I'm talking about lists right now, in addition to loops. We're gonna get to loops soon. I promise there's a point to this. Okay. So I would let's pick out the 2. That's index 0 of p, right? So p of 0, or p at index 0. Give me that thing. And there it is. I got my 2. Beautiful. All right, that's the thing. Let's get the 5 out. That's index 0, 1, 2, right? So if I go to index 2, that will give me the 5. Save that, run it. There's my 5. And then if you want 3, you could go 0, 1, right? It's index 1, or you could start from the right. You can be like, this is -1. -2 is another index that would get you to the 3, right? So like p of -2, that's another one, right? So p of -2 is the same as p of 1 for this particular list. Depends on the size, how they correspond, but that'll do it. So that's another, that'll pick out the 3 for us using the negative indices. All right? Can we follow that still? Does it make enough sense? Just yell at me if it gets confusing. But this is kind of the syntax, how you pick something out. It's also the syntax for changing something. So actually, you don't have to just use a variable name to set something. You could use an index of a list. You'd be like, p of 0. I would like to set that to something else right now. You can put it on the left side of an equals of an assignment. Be like, all right, p of 0, make it 7 now. Yeah. So you can use the same syntax. Oops. Syntax to change an index. And so now it's not going to be 235 anymore because I just reset index 0 to 7. Now it's going to be 735. That changes the list. So print p. Whee. And there it is. Now I got my 735. Cool. I think that's what I wanted to say. Are there any questions about any of that so far? We good? All right, it's your turn then. I will give you this code. And I have a question for you. Dun, dun, dun. So here, I'll give you this. It's right here now if you need to look at it. But I would like you, please, to go to the written ice page. I'd like you to get into little groups and say hi to each other. And then here is your task. You can elect a leader to enter in your answers. But let's say that I made a list called capital L. All right, L is this list of numbers. And I would like to get the 5 out. This number 5 right here. All right, I'd like to get the 5 out of this list. There are 2 ways to get it out, right? try to write some statements that kind of look like these, right, with prints and things. Try to write the 2 statements that would give you that 5 and print the 5 out. Does that make sense? See if you can find what indices it's supposed to be. And please enter in your answer on the written nice page. Are there any questions about the question? So try to find the indices for the 5 and print out the 5 using this kind of syntax. The list is not called P anymore, though. Remember that it has a new name. Remember what indices start at on the left side and the right side. Going to indices of L. It's called L now. Using that kind of syntax. Another few seconds, 30 seconds or so. Alright, is that enough time? Some of us didn't get it in there. So, complete your thought. We were all thinking about it, right? Did we have questions? Or are we confused? Or are we just not feeling it today? So I need to know. But the answer is going to look like this. Print something, right? To do it one way, and then print something else to do it the other way. Yeah? With that in mind, I'll give you another 30 seconds to get something in. They look like that. What do the indices start at? They start at 0, right? Start at 0 on the left, and then -1 on the right. You want to go way over there and work your way that way. Alright, 10 more seconds, and I'll take a look and see what we're thinking. See if it's right or not. It's okay if it's not, that's the whole point of this question. Let's see what you got. Alright, let's take a look. Thank you, those of you who got it in there. Looks like we found that it's going to be 3. We're thinking 3 for the first index. Good. the first way of doing it, and looks like we've all considered -4 for the other one. I think that's right. Is that what we've all agreed on? I think there's more than just 4 of us, so I want to make sure that we're understanding things. So please ask questions if you have questions. Let's see, I need to stop that. But yeah, I think we're getting it. Yeah, are there any questions from those of you who didn't submit? Like, are we confused, or we just responded together? Want to make sure we're getting it. But yeah, if we want to count indices, on the leftmost side is 0, right? The index of the 8 would be 0. That'd be 1, 2, 3 for the 5, all the way up to 6, right, for the 9. And then if you want to go backwards, your last index has another name. It's always -1. And if you want to work your way that way, this will be -2, -3. That makes 5 -4 as well. You see it? And that's -5, -6, -7. So everybody's got 2 indices secretly. And so for the 5, if we want to pick out the 5, it's either go to L, right? L is the name of the list. Go to L at index 3. Using that, kind of work your way from the left index. Or go to L -4. Work your way from the right index. Does that make sense to us? Are there questions about that? All right. Just want to make sure we're doing all right, because I'm eventually going to have a programming assignment about this. So, okay. Now we're ready for loops, right? I promised that lists were a perfect segue into this, but the idea of a loop, right, is like you got some code, you want to have it repeated, you want to come back around on yourself, loop around as many times as you want. What did loops look like in Scratch, right? It was this, like you had the most general loop in Scratch was like repeat until. It's like repeat until something, and so it's like repeat until some condition is true, and so they had some pointy thing to go there, and then you put like a bunch of code that you wanted repeated in the body of the loop there, in the body of that block. So how do you do that in Python again? It's going to look a lot like how we translated if blocks to if statements and if else's to if else statements. So it'll look something like this. You'll say something, you'll put a condition, then you'll put a colon, and then you'll tab over and be like, these are all the things. You keep tabbing over. These will be all the things I want done repeatedly, kind of thing. Right? As long as something's true about this condition. All right? So that's where we're going. So yeah, you know about loops already. I don't have to reteach you loops. I just have to teach you the new syntax in Python for loops. So yeah, in Python, we're going to, again, repeat a bunch of code, and that code is going to be indented this time, all right? And you can control, of course, the repetition, but the way of doing a loop in Python, the easiest way, the first way I want to teach you, there's a couple ways. The standard kind is called a while loop. So you'll say the word while, all right? So a while loop, what it does is it runs its body whenever you put and want repeated. It runs its body as long as a condition you give is true. So it's kind of backwards from the repeat until block from Scratch. It's like instead of repeat something as long as the condition is false and until it's true, it's more like repeat something as long as a condition is true, and once it becomes false, we stop. So it's a little bit backwards, but you'll get used to it. So here's kind of like in picture form how a while loop would work. It's like you have a condition. It's a pointy thing that could be true or false, right? You have your condition. The second you hit your loop, you're always going to check the condition first, just like the repeat until block would have. And as long as it's true, you'll run the body. Capital true for Python, right? As long as it's true, you will run the body of your loop. And I'll show you the real syntax in the next slide. Boop. As many things as you want repeated, it runs them when the condition is true. And then it always, because it's a loop, it comes back to recheck that condition. So as long as it's true, it'll keep running the body and going back. And that's what's going to happen. The second it becomes false, though, then it's done with the loop. Then it's done, false, and it goes on to the rest of your code outside of all that. Rest of your code. All the way down there. So yeah, it runs its body as long as the condition's true, and here's what it looks like. All right? It looks a lot like an if. You say while instead of if this time. While a condition is true, whatever it is, whatever your thing is that becomes true or false, we'll call it cond again. While that condition evaluates to true, and you tab over, right? Idle will do that for you. Tab. You indent, and then the indented stuff becomes your body, right? That's the body of the loop. This is the body. You keep it all on the same level of the while loop. That's what it's going to look like. You give as many lines as you want repeated, and it will repeat them as long as the condition is true. Eventually, the point is that the condition will eventually become false in theory. Okay? So it'll run the body as long as the condition is true and keep coming back to check that condition again. So as long as it's true, it keeps on rerunning that body. The second it becomes false, it stops with the indented part. It comes on down to like whatever's down here, the rest of your code after you've unindented again. Okay, just like for if statements. So yeah, that's kind of how it works. I guess the first loop that we kind of learned, besides the like repeat n times block and scratch, was like a forever loop. So a forever loop in Python would look like this. You'd say while, and then the while loop runs its body as long as the condition gives back true. And so we just want to make a condition that always gives back true. The word true is always true. Yeah, it's like while true is true, and it will always be true, have a body. And so this will be your forever loop. This will always get executed, whatever you put in here. Always gets executed. So that'll be that. So usually, I don't know if this is true always, depends on your program. Idle might actually ruin this for us, but Control-C is usually the way. If you have a program that's running forever, you can of course just click the X. But if you want to like stay in the REPL or something, Control-C a lot of the time in most programming languages is a way to stop your program. But you kind of have to be fast in idle. It might not crash. So let me show that to you. Let's have a forever loop. Forever loop.py. So we're slowly coming full circle. We're going to do some stuff that we've been doing in Scratch in Python. So while true, because true is always true, and it will run the body as long as it's true. It is true. It's true forever. Print hello world. So this is just going to print hello world until the end of time. Does that make sense? That's what this program is going to do. Just print a billion lines of hello world as long as you want to keep the computer turned on. All right? It kind of also implies that something else won't happen. So like if I unindent and say, like, all right, when the loop's done, I want to do something else, we will never get to this line. We'll never get here. We'll never print this. Does it make sense why we will never get to here? Because that loop is going to run forever. It will never finish. We'll just keep running the indented stuff, printing hello world until the end of time. Only if the loop were to stop would we get down to here, and the loop will never stop. You see that? It's interesting to think about. But here, let me run it. I don't know if I can type Control-C fast enough. It might just crash idle. But maybe your beefier computers are happier. Whee! Okay, yeah, I was able to do it with Control-C. But look at it. Control-C stopped it, but it just kept going. Whee! Look at all those hello worlds. And I typed Control-C to just stop it, get it back to normal. But yeah, it's just going to keep doing that forever. While true, hey, is true true? Yes, true is true, so I'm going to run the body. Come back to the condition. Is true still true? Yep, run the body. As long as this evaluates to true, run the body, and it will always. See that? Questions about the forever loop example? While true, it's the easiest way to do it. You're going to be like, while 2 is equal to 2, that's also always true, right? That's another way to do it. But while true is the easiest way. So there's that, and I think we are ready to like do interesting loops that don't always run forever. All right, so I think we're ready for a bigger example, a fancier example. Let's make a loop that iterates, right? Because loops iterate, we say they're going to go in some order from some value to some other value usually. And so let's make a loop using a while loop. Let's make a loop that prints the numbers from 1 to 10 out in order. All right. It will be cheating to do it this way, right? We can't do it like this anymore. We can't be print 1, print 2. That's the cheating way. All the way to print 10, right? Let's do it with a loop instead. So we need to find a way to have code that's repeatable, that somehow is going to print 1 the first time, 2 the second time the code's repeated, 3 the third time the code is repeated. You see that? That's what we need then if we want to make a loop out of the deal. So, okay. The secret is going to be use a variable, all right? use a variable because kind of look what's going to happen here. I guess I'll make a new file. Loops.py. I'm going to do it that way, yeah. So if I can't do this to print from 1 to 10, I need more options. I can't say print 1, print 2, print 3. I want code that's repeatable. I want to say the same thing, but like the first time it prints 1, the second time it prints 2. I want something that's repeatable. And the answer is going to be to use a variable. So I'll start a variable, I like to call it I in computer science. I'll start I as a variable at 1. That's the first value I want to print. And then kind of look what's going to happen now. If I say print I, do you see how that will print 1? Right now, because I started at 1. But, and then if I repeated the print, of course, it was just like print 1, print 1. It'll just keep printing 1 because I's never changing. But what if in between I changed I? Watch. If I say I equals I plus 1. Do you see how that would make I 2? I will change it. Make it 2 now. And what if I repeated that? Do you see how this would work? This is going to print. It's printing 1, 2, 3, 4 right now. Me duplicating this code. Do we kind of understand why it's doing that? We did this in Scratch, but it's a different syntax now. It's like, all right, I is 1, print I, make I 2. Now I is 2, print 2, make I 3. Print 3, make I 4. Print 4, make I 5. Do you see how if I repeated that code, it's the same code, but as I'm running it, the output's changing because the variable's value is changing. Isn't that cool? So that's the secret. If I repeated this code 10 times, I would print from 1 to 10. Yes? That's what I want. That's exactly what I want. Don't need to copy and paste. I got a while loop for that. So here's what I want. I want to, like, while something is true, do these things. Repeat these things 10 times. All right? So we kind of have to think hard about, like, all right, what is true when I want to do this? To run, like, print I, make I 1 bigger. Because that's what we're doing right now. That's what we decided that we can do repeatedly. That's what we want, repeatedly. We want to print I, and then increment I. Increment I. So like I started at 1, and then we printed it. We printed the 1 to make 1, and then now it's 2. Then we'll print the 2. Make it 3, increment it. Now it's 3. Does that kind of make sense what's going to happen there? And then we'll print the 3, make it 4. Print the 4, make it 5, all the way down to like it's 10, right? We still want to run it when it's 10. Print the 10, make it 11, yes. Print the 10, it will become 11. And then we'll come back to our loop. We don't want to print 11 when I is 11, yes? We're done. We only want to print up to 10. So that's going to inform what our condition should be. We only want to run the body and print like whatever I is right now when I is not yet 11. See that? As long as it's like less than or equal to 10, I would say. Does that kind of make sense? Because if it's equal to 10, that's fine. Like print the 10, make I 11, then when we wrap back around, now this is no longer true about it. Does that kind of make sense? That's going to be our condition. All right, please yell at me if you have any questions. But that'll do it. Be like, all right, while I is less than or equal to 10, do these things. Because like at the start, yes, 1 is less than or equal to 10. I'll print the 1. Here's the output. And then the next time, make it 2. Like 2 is still, like comes back to the condition as 2 less than or equal to 10. Yeah, sure. So it'll print the 2, make I 3, and it'll keep going, right? Up till 10. When I is 10, 10 is still less than or equal to 10. That's true. It'll run the body. Print the 10, there it is. Make I 11. And now when it comes back, is 11 less than or equal to 10? No. That will stop the loop. That's what we want. See that? This line is, this is incrementing, right? Increment. I. Are we seeing it? Questions about why that's going to print from 1 to 10? Is it making sense? All right. I will assume that we are happy unless you yell at me. What if we wanted to do it backwards? Like what if you wanted to count from 10 to 1? How would you do that? It's going to be a similar process, right? Similar process. Let's figure that out. So if I wanted to print from 10 down to 1, what does that mean for me? Like, how do I make a loop out of that? Well, first of all, if I want to use a variable, I need to use a variable always. The variable doesn't start at 1 anymore. It's got to start at like 10. Yeah? So now what is the process that's going to be repeatedly? What am I repeating? I want to print from repeatedly. I would like to print still my I, right? Print, it starts at 10 though. Print I. And then, like, I want to get ready to make it 9, right? Get ready to print 9, so make it smaller. It's not increment I, it's decrement I. Does that make sense? Like, that's going to be your new condition. Or not your condition, it's going to be your new loop. We'll have to figure out the condition still, yeah? It's like, all right, repeatedly print I, decrement I. That will work, right? Because it'll print the 10, then we decrement it, make it 9, print the 9, make it smaller to make it 8. So we print the 8, make it smaller, all the way down to, now we have to think about when do we want to stop this? Like, we still want to get to 1, right? Because we want to print the 1, make it 0. But then the second it becomes 0, we want to stop. We do not want to print that 0. Yeah? So that's going to be part of our condition, like the last value I care about. All right? It's not quite going to work the same as this. It can't be I less than or equal to. Like this can't be the thing. We want, like, our goal, we want the while loop to be true and do these things as long as something's true. We want to keep printing. While something. And it's not something like this. It's not going to be I less than or equal to 1 or something like that, because that won't actually work for us. Because when I starts out at 10, is 10 less than or equal to 1? It's not, right? So that won't even run our loop. So this is the wrong condition if you're going backwards. So it's actually just the wrong direction. Just the wrong direction. We want to keep printing while, like, honestly, what we want to do is we want to keep printing while I is within the range, right? While I is, you've seen this kind of syntax in math before, right? While I is between 1 and 10, yes? That's what I want. Yes, if I could make that in code, that would work out. You can do that with like less than or equal to's and ands, it would work. But it's kind of redundant because if I starts at 10 and it's always getting smaller, then just like automatically it's always going to be less than 10. Yeah, so I don't even need that condition. So really, this is my condition of my loop, right? Because I is getting smaller. Like, well, 1 is less than or equal to I. That looks a little backwards though. So I just flip it around while I is greater than or equal to 1. Yes? Because that's what we want. While I is greater than or equal to 1, we'll do it for us. Because like at the start, when I is 10 greater than or equal to 1? Yes. Yes, it is. Print my 10, make it smaller. All the way down to 1, right? Is 1 greater than or equal to 1? Yes. Print my 1, make it 0. Once I get to 0, is 0 greater than or equal to 1? No, you see that it'll stop my loop at the right time? That's what I want. That is what I want right there. So that's how you think about it. It's like a backwards kind of condition. So the less than in terms of our last value. If you're going downwards, it's a greater than in terms of your last value. So it's going to be very similar. Print. Let's have like a separator here so we can see our new stuff. Let's do the same. Let's be like, all right, I is... R starts at 10 this time instead of starting at 1. We're going to do our backwards way. So repeatedly, I would like to print I and decrement, not increment, decrement I. That makes it smaller each time. And I want to keep doing that. I'm going to keep printing and decrementing as long as I is greater than or equal to 1. That's what we decided. And there's my 10 to 1, stopping right when it needs to. Does that make sense? So notice the different direction of the condition there versus like going up versus going down. Any questions about that? Have we seen it? All right. There's a lot of games we can play with this, just like doing the things we did in Scratch again. So let's... instead of printing out the numbers from 1 to 10, let's sum up all the numbers from 1 to 10 and get the summed value, okay? So we will, just like we did in Scratch, we can keep on using our I variable. Like that can be our number that we want to like add up, like starts at 1, then we add it into some other place though. So like we'll make like a sum variable, started at 0, like add the 1 in, increment it, yeah. Make it 2, add the 2 in. I guess the first time it's 1, add the 2 in, now it's 3, right? Make it 3, like have I range over the numbers I want to add and have sum hold their sum, right? Keep on adding it in each time. Add the 3 in to make it 6. And eventually, right, this will get to 10, add the 10 in to make it, I think it's 55, right? And then make it 11, just like for our loop, but that's when we want to stop. Once it hits 11, do not add any more numbers into sum, we are done. That'll do it. But it's essentially the same as printing, it's just like instead of printing, we're taking that number that I is right now and shoving it into a sum variable. Keep on incrementing by that. Okay? That's what we want. So let's see here. I think that's what I want to do. That's going to be mostly this code all over again. I'll just copy and paste it. Put it down here. Let's have some of that. And I think I just pressed enter on a bunch of indented code. I think it probably isn't happy about that. There we go. All right, so this is the new stuff. So this is still printing from 1 to 10 right now. But we can easily change this to start like a sum variable at 0. And then instead of printing that I values, I is ranging, I is 1, I is 2, I is 3, instead of printing it, we'll add it in to a sum variable. Sum equals sum plus I. So I'll take the current value of I and place it into the sum. Add the 1, add the 2, add the 3 each time. See how that's going to work? And that's what I want. And then at the end of that, like once this loop is completed, like I is 11, but like that'll stop the loop. We didn't actually accidentally add the 11 in, but I will end up being 11. That's what's going to stop us. But once this loop is finished, unindent, once it's done, it's ranged through the values, it's placed them all in sum, so that means sum holds the answer. So sum, once we're done, once we unindent, once the loop's over, sum now holds the correct sum of 1 plus 2 plus 3 plus all the way to 10. And if I print that, I'll get to see the answer. And there it is, there's the 55. Cool. So instead of printing each I value, we took each I value and added it into a sum variable. Is that coming back to us? So yeah, stuff we've done in Scratch, but now we're doing it in Python. How fun. We still good? Questions about this? Alright, just shout out if you think of one. But I think now we can kind of talk about lists. A list, it's once you have a list and you got it from the user, you got a bunch of numbers or something. The second you have a list, it kind of screams the idea of I would like to go through every element of that list. That's why I taught lists first. So let's do that. We can do that. You can go through or iterate through a list, we say, with a while loop by visiting each of its indices. Yeah, so if this is my list, X, I can go to index 0, 1, 2, 3, 4. How do you know when the list is over? You can use the length. Like your first index is 0, your last index is 4. How'd you get to the 4? It's however big the list is minus 1. So it's the length of your list minus 1. And len will tell you that length. Does that make sense? Because len is 5, and then the whole thing minus 1. That makes 4. That's always your last index because they start at 0. So if you can just make a loop that ranges from 0 to 4, yeah, and then use that number that you're working on right now inside of your loop to go there. So this is some key syntax that we'll have to remember here. So that will always work for any list. That will always give you its rightmost index. So yeah. So that's kind of why, it's one of the reasons why we use variables called I. Like I is short for iteration variable, is short for index that I want to go to, people like I. But kind of watch, right? What will happen? I want to have I range over all of the valid indices I want to go to in this list. It's like while I starts at 0, that's the first index I want to look at. While I is a valid index of my list, while it's less than or equal to the length of my list minus 1. That's it. And then when you're in the loop, you can mess with and use X at index I. Does that make sense? Because then I is going to have 0, 1, 2. It'll have all the valid indices. If you go there, you can get the value of that index. And if you're working your way from left to right like that, you'll get them in order. And then, of course, you have to say I equals I plus 1 to move along. Otherwise, you'll never end. This 1, but that's the secret. You can range over the indices, go to those indices. Won't that be fun? So, yeah, let me show you that. And that will be the last example here, in this file at least. So one more little separator. And so let's do this. Let's be like, all right, let's make a list. I'll call it L. L equals some stuff, 5, 6, 7, 8, 9. They don't have to be in order, like 1, 13. Be in any order you want. And I would like to range through all of the indices of this list. I don't even have to count. I don't care. Python will count for me. So I'll start the index variable I at the first one I want to go to. So index 0, I want to start the left side. So 0 is always your left side. Yeah, 0 is always the first index of every list. So that's useful knowledge, right? And then from there, I want to do this kind of thing. So 0 is always my first index, and while it's still a valid index, while I is still a valid index, while it's less than or equal to the size minus 1, that's the last one I want to go to, right? The length of L now, because I'm calling it L, minus 1. That's the secret. So while that's true, then I can go to somewhere. I can use L of I in my loop. Yeah, that's what I want. So ln of L minus 1 is the last index of every list, if it's called L at least. That's how we get there. And now I can use that index to my advantage. I guess, yeah, now you're allowed to just like do stuff with L of I in your loop. You can reset the values there, because like you can put it on the left side, like L of I don't know, make it 1 bigger or something if you want to do it that way. Or you can just print it. Like, let's just print it maybe. You can say print L of I, go to that index, print out the value, and then always, we were working on index 0. The next time we wrap back around, we want to index 1, index 2 after that, index 3 after that. We always want to increment I. Can't forget that. I equals I plus 1. And so the first time I is 0, we go and we print L of 0. Now our I of 1, right? Now I is 1 after that. We come back. Is 1 still a valid index? At least for this list it is. It's not less than or equal to the size minus 1, or it is less than or equal to the size minus 1. It's not too big yet. We print L of 1, make it 2, print L of 2, make it 3. You see how it's going to work? And that will go to all the elements of that list in order. It'll give you the values there. All those guys. You see them. Does that make sense? It's just that we're ranging again, just like we were printing from 1 to 10, but like the I is useful. The I is getting us somewhere rather than just like printing the I value. We're using that I to index into a list and get the stuff inside, get the elements inside. That was the word, right? I think that's pretty fun. Are there any questions about that? So like this is what the data scientists do all day, right? They're going to get like a big long file of data from their company, and like they're going to work through it. Like, you can find the average of a bunch of numbers. Like, you'll use lists all day long in statistics, data science, stuff like that. So that's useful knowledge. And I think let's do something even more fun than printing out numbers. Let's bring this back to Turtle Land. I think that'll be fun. So let's do this. Let's draw 50 squares, because we can loop it now. It doesn't have to be copied and pasted. Let's draw 50 squares of random sizes, and then let's have each square have a random color as well. I'll show you that. All right. So let's take some of our code from before, that code that drew a bunch of random squares. This one. So this is the code from last time. I'm going to copy and paste it into a new file, because this was the old sad way where we didn't know about loops yet. Make a new file for today. Boop. And I'll call it randomsquares.py. If you want to follow along, you can copy and paste the stuff from the code from class. If you want to go on Canvas, it's all still there from the last lecture, or from the last programming lecture. And do you remember what was happening here? Like, we were asking the user for a color. Let me just, I don't know, let's just set the color to something right now. It's like be blue. Like we were setting the color from something the user gave me, but let's not deal with that right now. Let's just have it be hard-coded as blue right now. And then here was the code that drew a single random square, right? A random size, random location with whatever the fill color was. And then I copied and pasted that code 5 times. It was disgusting, yeah? So, I mean, it'll work. That will run it. That will make 5 squares. But it's kind of boring. And definitely not as cool, right? Because we're hard coding, or like we're just copying and pasting things. How many lines do we have? Idle will tell us down here at the bottom. Oops. We've got, what, 117 lines. Well, we could have made this part of a loop, right? Could have made this the body of a loop. So like that's where I want to go. So let's use a variable, like an I variable, to range from like 1 to 50. Yeah, we don't have to print 1 to 50. We just have to use that to control how many times we're doing stuff. So let's loop 50 times using a variable, because that would make it so that I don't have to copy and paste. I'll just have one of these bad boys, just like that. I'll take the first one only. The code gets so much smaller after that. It's like this is just one thing, one set of code that creates a random square, yeah? And that's what I want to loop. I want that to be indented, right? I want that to be part of my loop. So I'll make an I variable again, I equals 1, while I is less than or equal to 50, do all this. Does that kind of make sense? That's what I want. I don't have to print I, I'm just using I to count. And then of course I need to like move it along, I equals I plus 1. Can't forget that. But do you see how I will range from 1 to 50? That's 50 numbers total. And it will therefore also run whatever code we also put in here, drawing squares. You see that? It'll draw 50 random squares. This is beautiful. And it will work. It's just going to be a little slower with the default speed of the turtle. So I can say turtle.speed, be like fastest speed possible. Well, look at him go. And I've hard-coded blue right now. Well, there he goes. He's drawing 50 random squares. He's counting with the I variable. And he's making beautiful abstract art. I guess it looks cool with all one color, but it'll look even cooler with different colors. All right? So let's make sure we all understand what's going on right now. This is the crux of the code right now. Are there any questions about what's going on here? Does that make enough sense so far? We got an I variable. We're ranging I from 1 to 50. And we're only using I to count. We're not printing I. We're not doing anything like that. It's like I plus I equals I plus 1. And then whatever code else we put in here is coming along for the right. It's also being repeated. And that's the important code for us, at least now. It's like the draw a square code. So like draw 1 square. It's being repeated 50 times. So we're drawing 50 squares. Beautiful. All right. And now, instead of hard coding blue, I would like to pick every round, every time we're about to draw a square, I'd like to pick a random color. That's what I want. That is my goal now. So what we can do to pick a random color, one way to do it at least, is to make a list of colors. Because you can make, here, I don't know if this is the right time to say it, but like you can have, we've made lists of 1, 2, 3. That's a list of integers. You can make a list of floats, 3.14, 1.5, 2.0. That's fine. You can, of course, have lists of strings like hi, mom, hello. You have a list of strings, right? If you're coming from a different programming language, let me at least show you something that you can do. This will make you feel very uneasy. If you've learned a different programming language, you can say this. You can be like 1, 2, hi, 3.14. Python's happy. Python doesn't care. You can put different types and different indices, but we're just going to make a list of colors. We're going to make a list of colors. And then we can go to a random index of that list, right? Because we know like it starts at 0, goes to size -1. Pick a random number within that range, go to that element. There will be a color there that we can use. That's what we want. That's what we want. So instead of hard coding blue to be the color, let me fix it each time. Each time we run, or I guess here I can kind of steal some of that. Before we do anything, we're going to like pick a random fill color. Pick a random fill color. And let me just do it hard-coded. And then also again, like this loop will run its body 50 times. That's the point of this loop. I's ranging from 1 to 50, I getting bigger by 1 each time. So we're going to run its body 50 times. And so to pick a random color each time before I draw a square, how do I do it? I'm going to make a list of colors. You can make the list as long as you want, but I'll just make it the colors of the rainbow for now. Like red. These are all things that I could give to set fill, right? Orange, yellow, green, blue, purple. It understands all those. So I've made a list of colors. It knows other ones, like there's names you can give it, but like that's a good start. And so that's a list, right? And do you see how if I go to a random spot of this list, I will get a random color? That's a way to get a random color. So what does that mean? What's a random spot? It's a random index, right? If I go to a random index between 0, 1, 2, 3, 4, and 5, right? But I didn't even have to count. I could go to size length minus 1. That's what I want. I want a random index into this list. Random index equals, it's random.randint again, right? Just like we were doing down here. It's always between 0 and then what's the biggest index? We've noticed that it's 0, 1, 2, 3, 4, 5. So you could just say 5 here. Or you could let Python do the work for you, because maybe you typed a lot of colors, you don't want to count them. Python can do the counting for you. You can say, I want the length of my colors list minus 1. Does that make sense? It's like it'll do the counting for you, and that's always your last index, is the length of your list minus 1. That's beautiful. That will work. And then, like maybe it chose index 2. That's my random index. If I now say, in a bigger place, if I now say like colors, go to that random index, and it was 2, do you see how this would result in, it would pick out 0, 1, 2, the yellow. Give me the string yellow. And then I could use that to set the fill color. It would be perfect. That's my secret. That's the answer here. So I can say turtle dot fill color that particular color. You see how it's going to unwind? Like it's going to do this first. It's like colors go to that random index, whatever one it picked. Like maybe it was index 0, so give me the red. This would turn into red, right? And then set the fill color immediately to whatever that was. Set it to red. You see how that's going to work? Does that make sense to us? And it will be different every time because it's a new random number every time you say random.random. Give you a random, like it's going to roll a die, kind of. That's it. Got a big long list of colors. It'll pick a random one each time to set the fill color, and that's what's being used between the begin fill and end fill, right? That's what's going to be used to fill in my square. And with that, look at it. Look at it go. It's beautiful. Maybe you could choose more harmonious colors if you wanted to, but that was good enough for me. Beautiful. And so you got some very pretty abstract art, and it's going to be different every time because it's random. Look at it go. But every time it's about to draw something, it's picking a random one, picking a random color to use out of that list of colors that I provided. It's able to try them all, right? Go to, it could be as small as 0 or as big as size minus 1, length minus 1. So any of these indices are valid, and go to whatever random one there is. That will give me one of those colors. One of those colors, set the fill color to that, draw my random square, and I'm repeating this code 50 times because I'm in a loop where I is ranging from 1 to 50. There are 50 numbers between 1 and 50, right? Inclusive. I equals I plus 1. This is some fun code to study, I would say, but is it making enough sense right now with words? So yeah, I highly encourage you to take this code once I give it to you and play around with it. But I think that's the example. Yeah. Any questions about this or anything else that we're using? So this is a nice combination of a lot of things, right? We've got loops, we've got lists, we've got random library stuff, turtle library stuff. So I think this is a good one to study and build on top of. All right. So you got some cool abstract art out of the deal, and the turtle is set to the fill color of the last thing you drew, and so you got a turtle in the picture as well. Very pretty, and it is different every time. I love it. There's a way to make the turtle even faster if you don't want to even watch him do anything at all. But I will let you consult the documentation for that. But lovely. So yeah, randomness is your friend. Lists and loops are your friend as well. And I think that is all that I have. So if we are good with this, let's just make sure. I got nothing left to give to you. Yep, it was just the lecture for the day. You've already got an assignment. Maybe this will help you with your assignment. I don't know, you can incorporate loops if you want to. But I think that is all that I want to record, at least.